Hello everyone, welcome to chapter 5 section 2. Today we are talking about probability rules. So now we're actually getting into calculating probabilities, not through simulation but through formulas and stuff. So first we need to define some vocabulary. A couple things. Sample space is the first one. So for any chance process, flipping a coin, rolling a die, anything. A sample space is just a list of all the outcomes. So if you're rolling a die, that would just be the list 1, 2, 3, 4, 5, 6. If you're flipping a coin, it would be the list heads or tails. If you're flipping 2 coins, it would be you can get heads heads, or you can get heads tails, or you can get tails heads, or you can get tails tails. So the list would be longer because you have more combinations of the different orders you can do things when you flip 2 coins at the same time. Something like that. The next thing is a probability model. So a probability model is basically just again, a list, but you're describing in that list what everything in the sample space is and the probabilities for each thing in the sample space. So a list of the things that could happen and the probabilities of them happening. That's all. For example, let's say we're trying to find the sample space of rolling 2 dice. So when you roll 2 dice, you can, you have 2 numbers that you would land on. So all our different combinations would be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and so on. So I made a little table just to list them all out. Okay, so that's just an example of a sample space. You don't have to list it in the table. You could just list it. Sometimes you'll see it listed in the squiggly brackets this, these. And so inside would just be the list separated by commas, something like that. So if I were to do an example of a probability model dealing with rolling 2 dice and then finding its sum, then my sample space, because I'm summing all the different combinations of numbers I can get when I roll 2 dice, the smallest number would be 2, because if I get a 1 and a 1, or if I roll a 1 and a 1, the sum would be 2. The biggest sum I could get is a 12, because the biggest numbers I could roll is a 6 and then another 6. And then everything in between. So looking at my sample space, there is, out of my 36 different combinations, there is only one way to get a sum of 2. So the sum of rolling a 2 would have a probability of 1 over 36, because there's one opportunity for you to do this out of the 36 total. Okay, to roll a 3, we can either roll a 1 and then a 2, or we can roll a 2 and then a 1. So the probability would be 2 out of 36. Rolling a 4, I can do a 1 and a 3, a 2 and a 2, or a 3 and then a 1. So here, because we have the 2 dice, it doesn't matter what order, they both count. So the probability would be 3 out of 36. And notice how as I'm listing out my probabilities, I'm not reducing my fractions because, fun fact, we don't have to reduce our fractions. Yeah! So on the AP test, as long as your fraction is equivalent to the answer, decimals, percent, fractions, reduced or unreduced, they all don't matter. Whatever you want, whatever your heart desires, you can list your answer out that way. Okay, so I've just gone ahead and found the rest of the probabilities for this probability model. So right here, I made it into a little table, but as long as you have some sort of list where it lists out all the different outcomes and all the different probabilities, that counts as a probability model. Okay, one more vocabulary word to talk about right now is an event. So an event is just any outcome or a combination of outcomes in a sample space. So this is more like when we say find the probability of this, that this part would be the event. So an example would be if I'm still rolling 2 dice, we could find the probability of rolling a sum of 5. So that whole rolling a sum of 5 is considered an event. We usually use letters to denote this, so usually capital letters. So I can say letter A, capital A, is going to stand for rolling a sum of 5, and then capital B is going to stand for rolling a sum that's odd, or something like that. So rolling a sum of 5 would just be one outcome in the sample space. Rolling a sum that's odd would be a combination of things, because now I can roll a sum of 3, 5, 7, 9, 11. Those would all count as a sum that's odd. So yeah. So now let's actually get into the probability rules. The first one is simple. We talked about it last video already. The probabilities of any event A has to be between 0 and 1. So in math, we like to, not use words. So in symbols, we use this capital P parentheses A. It's kind of like us saying like f of x, how when we deal with functions in math, we would write f of x. So here P of A just stands for the probability of A, where A stands for some event. And since it has to be between 0 and 1, we could write it with, inequalities. So remember, a probability of 0 just means that event A will never happen. A probability of 1 would mean that event A would definitely happen. The second probability rule I want to talk about is that the probability of the sample space happening is equal to 1. Okay, so remember we just said the probability when it equals 1, it means it'll definitely happen. So when we talk about the sample space, we're saying like for any chance process, something within the sample space happening has to happen, which is like, duh, like obviously something's going to happen. So let's say we're flipping a coin and the sample space is heads or tails. When I flip a coin, of course, either heads or tails has to happen. So that's why the probability of the sample space happening is 1. And even if you account for the fact that, like, what if you land on, like, where your coin lands vertically, where it's neither heads nor tails, well, there's still a probability of that happening. So then in that case, if you're counting that, the sample space would be heads, tails, or vertical landing. Okay, so even then, if that's your sample space, then something still has to happen. So the probability would still be 1 of the sample space happening. Okay, the next rule involves a vocabulary word. So this is the complement. So we use like event A with a little like exponent of C stands for the complement. And it's not always going to be used as an exponent of C. I've seen depending on the textbook, like A with a little apostrophe or like A prime, but it's always going to be defined for you when it's the complement. So our book just uses the exponent of C to show that it's a complement. A complement is just the opposite, so like not A. So let's say, for example, that A was the event rolling a 6 on a die. Then the probability of rolling a 6 on a die is just 1 out of 6 because you have 6 total outcomes. One of them is a 6. But then not rolling a 6 for not A would be rolling the numbers 1, 2, 3, 4, or 5. So 5 out of 6 chances to do that. Or if you want to use the formula, 1 minus 1/6 would give you 5/6. Another useful example of this is anytime a question asks for the probability of at least 1, whatever thing that they're talking about, at least 1 just means you want like 1 and above, right? Because at least means 1 or more. So really what you don't want is just none. Like if you have like 10 friends and you're looking for the probability that at least 1 friend will come over to your house, you really just don't want no people to come to your house because that would be lonely and sad and ugh. Okay, so the opposite of none would just be, the opposite of at least 1 would just be none. So if we find 1 minus the probability of none, then that would give us the probability of 1 or more. The next probability rule has to do with mutually exclusive events. So first, mutually exclusive events are 2 events that can't happen at the same time. Another way to call this is disjoint. You'll see it both ways depending on whether you're looking at the textbook or the AP test. They mean the same thing. Disjoint also means that the 2 events can't happen at the same time. So when this happens, if you have 2 events that are mutually exclusive or they are disjoint, then the probability of A and B would be 0. Because if they can't happen at the same time, then the probability of them happening together would be 0. Makes sense. And the last probability rule I have for you today is the addition rule. So addition rule is when you're trying to find the probability of A or B happening. So it's like we don't care whether we get A or if we get B. Either one happening we are happy with. So the probability for that would be to add the 2 probabilities together of each individual thing, but then subtract out the probability of them happening together at the same time. The reason why you want to do this is because when you find the probability of one event and you add it with the other, if they can happen at the same time, you've now counted it twice. And so that's why we want to subtract out, like, so that we don't double count. So that's why that's there. But let's say we have 2 events that are mutually exclusive. So if A and B are mutually exclusive, then the probability of A and B would be 0, because we know that they can't happen at the same time, then you can just add them together, because if they can't happen at the same time, that means we would never double count them. And let's do an example of this. Okay, so let's say, for example, that event A will stand for rolling a 6 on a die, event B will stand for rolling an even number on a die. So if we're trying to find the probability of A or B, meaning I want to either roll a 6 or an even number on a die. Well, okay, so if we just think this out, because this is a pretty basic probability problem. Rolling a 6 or an even number means that I would want to roll numbers like 2, 4, or 6. Okay, so if I were to just count out the probabilities, it would end up being 3 out of 6, because there are 3 options that would include what I want out of the 6 total in the sample space. So if I were to follow this formula, we would have to find the probability of A, add it to the probability of B, and then subtract out the probability of A and B. So for us, the probability of A would be the probability of rolling a 6 on a die, and that probability is 1 out of 6. And then we're going to add that to the probability of B, so rolling an even number would be 3 out of 6. Okay, so just adding this right now, we have 4 out of 6, but remember that whole double counting thing? Because 6 counted into both of those events if I rolled a 6, because it was an even number and it was a 6 that I also wanted. So I would have to subtract the probability of A and B together. There is one way for us to do this. So I'm going to subtract out the 1 out of 6, because this 1 out of 6 was rolling a 6 and rolling an even number at the same time. So then in the end, oh, cool, this program automatically calculates things for me when I press equals. Okay, 0.5 or 1/2 or 50%. So again, like I said, when we find answers to probabilities, it doesn't matter how you write your final answer. A fraction, a decimal, a percent, they all mean the same thing. Okay, just a few more examples so that we can get a better understanding of how to find probabilities and whatnot. So first I want to talk about ways to display probability models. So earlier I said we could just make a list. We also said we could make a table. So another way we could do is a two-way table. So we've done these back in like chapter 1. Remember, two-way tables just showed like 2 variables really. And it has a total in it. Those are the marginal distributions. The stuff inside is the conditional distributions, all that good stuff. But they're also very useful for us to find probabilities. So like dividing by the totals or whatever. So here's an example. What's the relationship between educational achievement and home ownership? A random sample of 500 U.S. adults was selected. Each member of the sample was identified as a high school graduate or not, and then as a homeowner or not. So we're trying to see if there's a relationship, if we can find probabilities of these two things happening. And so this two-way table was given to us. So this displays not the probabilities, but we could find the probabilities using this table. Another way to display our probability models is a Venn diagram. So I can actually use this table to make a Venn diagram. So hopefully you remember Venn diagrams, you got the 2 circles with an overlapping part in the middle. What people also usually forget is that there's technically also a big rectangle around the 2 circles, because not everyone falls into the 2 circles. So if your population is like, you know, all US people or whatever, and we're talking about if they're a high school graduate or a homeowner or not, the people outside of the Venn diagram would be the people who like are neither of those things. Because in the middle, you would have to be a homeowner and a high school graduate or so on. So when we draw our Venn diagrams, the easiest way to always start in the middle. So the people who are both a homeowner and a high school graduate. In our table, our two-way table, that would be these 221 people right here. It's easiest to start at that point, whether you're given a two-way table or not. Just trying to give hints here. Okay, so then we also want to fill out the rest of our Venn diagram, the rest of our circles. So in this entire circle of homeowner, remember the part in the middle would be like if you're a homeowner and a high school graduate. So like this section over here is when they're a homeowner but not a high school graduate. So homeowner but not a high school graduate would be these people, that 119. Okay, and keep in mind, if you're looking at this entire circle of homeowners, this everything in the homeowner circle, these two sets of numbers, the 119 and the 221, should add up to everyone who was a homeowner, whether they are a high school graduate or not. So when you add up 119 with 221, you should get this 340 number, because that was the total number of homeowners. So for the high school graduate side, we should be finding these numbers a similar way. So in this section of our Venn diagram, we are looking for high school graduates who are not homeowners. So that would be these people here, the 89. Okay, and again, if I added up everyone in the entire circle of high school graduates, I should end up with 310, because that's everyone who is a high school graduate. Okay, then we have the outside rectangle part. So outside rectangle means that they are not a homeowner, nor are they a high school graduate, and we've got 71 people in that category. So we would need to have 71 written out there. Okay, so now if I add up my entire rectangle of people, this should all add up to 500 because I had 500 people total. Okay, so let's find some probabilities using our either the two-way table or the Venn diagram. So suppose we choose a member of the sample at random, find the probability that the member A is a high school graduate. So let's start there. If we're looking for a probability that the member is a high school graduate, we are looking out of like all the people total, because we are looking for members of the sample and there are 500 total. So I always start by listing out like what is the total number of items that I can have, or what is the total, like the sample space. So we got 500 people to look at. So out of 500, the number of them who are high school graduates, there were 310. And I can find that either by looking at my two-way table, or if I looked at all of my high school graduates by adding those two together in the Venn diagram. Cool. And again, like we said, decimal, fraction, reduced or unreduced, or a percent, all of those answers are good. I already have a fraction set up. I don't care whether it's reduced or not, so that's my answer. Cool. So the next part, let's find the probability that it's a member who is a high school graduate and owns a home. So again, we're looking at the total of 500 people, because we want to know out of those 500 who or how many are high school graduates and own a home. So that would be the 221, because they have to do both. Okay, and again, I can find that using the two-way table or the Venn diagram. Okay, last one, we are looking for the people who is a high school graduate or owns a home out of the 500. So this is an or problem. Remember, we had that formula we could use, so we can find the probability that they are a high school graduate, which was 310 out of 500. We can add that to the probability of them owning a home, which would be, owning a home would be 340. But then that ends up double counting the people who are both a high school graduate and own a home. So we'd have to subtract that out, which was the 221 out of 500. So doing that math, I end up with 429 over 500. And if you think about this just in terms of like logic, if you're okay with finding a person who is a high school graduate or owns a home and you don't care which one they have, if you look at a two-way table, that's basically looking at the people, basically anyone who just is not either thing. So if we added up these three together, we would end up with the 429. Or if we looked at in the Venn diagram, these three together, the 119, the 221, and the 489, you would get the 429 out of 500. All right, that's it for this section. Everything we know about probability rules and our probability models. Thanks for watching. Bye.